another technique. So remember yesterday we started looking at the natural logs for things. But remember that when we made our natural logs, right, even when we were using u sub, we needed our u to be in the bottom in order for it to work. Does that mean my du to be able to be on top or up to the side? I need to be multiplying it. And so that worked as long as the degree of the top was smaller than the degree of the bottom. Because then we could let the stuff on the bottom be my u, and then my top usually ended up being the du. However, we run into problems if the top degree is is bigger than the bottom degree. And that's where long division comes in handy. So when the degree of the numerator is larger than the degree of the denominator, use long division first. And then integrate. So again, remember that we're just kind of building this toolbox of different methods that we can use to integrate things. So first we just had our power rule, then we learned our trig rules, we learned how to use sub, right? We're just trying to build it out so where we can integrate more and more things. And so if we run into a place where my degree of the top is now bigger than the degree of the bottom, we're trying to add in another way that we can integrate that stuff. But as a reminder, we'll also do some long division to remind us how we do it. So remember the polynomial on top is called our dividend, and that's what's going to go in the inside. Okay. And then our divisor, or whatever's on bottom, goes on the outside. Take our first term and we're going to look at what do I need to multiply 4x by to get 8x squared. 2x. And we multiply, so 2x times 4x gives us 8x squared, which is what we want. And then 2x times 1 gives us 2x. And then what do we do going down? Subtract. Yep. So 8x squared minus 8x squared gives us 0, right? Which is what we want, because we want that first term to go away. And then 6x minus 2x gives us 4x. So then remember that our next step is to bring down our next term, which in this case is 3. And then we start the process all over again. We say, okay, what do I need to multiply 4x by to get 4x? Nothing but, or just say 1, yeah. So then I have 1 times 4x gives me 4x plus 1. Again, I'm subtracting. So 3 minus 1 gives us 2. Is there anything that I can multiply 4x by to get 2? No. So what is 2? The remainder. Okay. And remember, just like when we have like a improper fraction, we can write that as a mixed number, where it's like a whole number and then the fraction to the side. We can do the same thing here. My whole number, or basically your quotient, goes first, right? And then we write our fraction off to the side. So I have 2 divided by 4x plus 1. And so notice that like, if I was wanting to take the integral of this thing, my top is bigger than the bottom, and so I couldn't do u sub from the beginning. But now, once I have done my long division, okay, these first two, I'll just use the normal power rule. And then this last one, I can now apply u sub because it looks very similar to the stuff that we did yesterday. Yes, no, maybe so. Right, so let's do the fifth one. So notice I have 5x squared plus x minus 1 on top, and then x plus 1 on bottom. So if I tried to do u sub, right, I would want my u to be the bottom, but what is the derivative of x plus 1? Just 1, and so that's not super helpful. And then if I tried to make it the top, the derivative of 5x squared does give us an x, but then that means that like our du would be on bottom, which just causes issues. Okay, so I can't use the u sub here. But what I can do is we're going to simplify first. So again, what's going to go on the inside here for my long division? Huh? The numerator, our 5x squared. Alright, and then our x plus 1 goes down the side. So then again, what do I need to multiply x by to get 5x squared? And remember that we subtract as we go down. So we get a 0 and a negative 4x. Agreed? Okay. And then my next step is to bring down my negative 1. And then I have to cross this over again. What do I need to multiply x by to get negative 4x? So I get negative 4x minus 4. Again, I'm subtracting, so I get 0. And then what do I get for my remainder? Positive 3. Yeah. Be careful there because you are subtracting a negative, so that flips it to be positive. Okay. So now, my 5x minus 4 comes first. And I have a plus 3 over my original divided. Which now that's much easier to integrate. Yes? So what can I do on the first two? Yep. So what's the antiderivative of 5x? So add
5
1.
over 2x squared.
Yeah. Add 1 to 1, and then divide by our new exponent. And then our antiderivative of negative 4 is just negative 4x. Yes? Now on this last one, what are we going to have to do? Yeah, we are going to have to do a u sub. So what would our u be?
X plus 1.
Whatever's on the bottom. Which is nice because notice then our du is just dx. So we just end up with a 3 divided by u du. And hopefully you recall from yesterday then that my antiderivative of 1 over u, or in this case 3 over u, is going to be 3 times the natural log of the absolute value of u. And now that I don't have any integrals left, what do I have to make sure that I add? The c. And then my last step is just to plug my x's back in. And that would be my answer. These do get a little bit long for your answers, because remember I'm doing the long division first, so you're going to have at least like 1 or 2 terms that I'm using the power rule for, and then you're going to have a natural log after that most of the time. So that, well, not that they're hard, it's just your answer is a little bit long. What questions do we have there? Do we feel like we could do one on our own? Maybe? Okay. Now there is something that we do need to be careful about on our setup here. What's different about my x cubed? So I go from x cubed to what? 4x. What are we missing? Squared. So remember when we're missing a term, we have to put a placeholder there of 0. So we need to put a placeholder of 0x squared. What do we get as a remainder this time? You should get -9. divide by anything. So I just get the natural log of the absolute value of x plus 3 plus c. Just no biggie. What questions do we have there? So really the place that people tend to make the most mistakes, and it's not even like because y'all don't understand it, is with the long division, because they'll drop a negative symbol or multiply incorrectly or add wrong or something like that, so then that just throws off your answer. So just be careful as you're going through those, that you're adding and subtracting correctly. Let's look at one more. So this time I'm dividing by an x squared, and so this is a good example of why it's more helpful for us to use long division than it is for synthetic division. Because remember, I cannot use synthetic division for this one, because if I have an x squared on the bottom, I can't use synthetic division. There's going to be a lot of those out there that we can't use synthetic division on, so that's why we just practice the long division, because it works on everything. Well, this is going to start the same way. I have 7x cubed plus 11x squared plus 7x plus 5. What do I need to be careful about on my divisor this time? I'm missing an x this time. So remember that rule applies for both the inside and the outside. So I do have to have a placeholder of 0x there. So I need to multiply x squared by a 7x in order to get 7x cubed. If I subtract, I get 0. Yes. Plus 4x squared plus another 0x, and then bringing down my plus 5. So maybe. So my addition right there. Yes, no big. 7x cubed. No, that should be a 0. This is like I thought this was 1. There we go. That should be an 11x squared. Agreed? Yes, let me. 7 times 0 is 0, not 7. Okay. So that makes this an 11. So that makes this an 11 at the end. No, sorry, that's still 5. That should be this. There we go. So now, subtracting 0, 0, 5 minus 11 gives us -6. Which is why I said double check your work, right? 'Cause it's easy to make arithmetic errors there. Yes, I'm moving. Okay, so now what am I going to rewrite my integral to? What comes first?
7x plus 8.
Okay. And then what?
Minus the remainder.
Over Okay, so what do we want to do on this last one? Okay, what would I make my u? Okay, so what would our du be? 2x. The 2's not an issue, right? We can get around the 2. But do I have an extra x there? Nope. And I can't just like manufacture an x. Yes, no, maybe. So we're going to have to think back a little bit. Does 6 divided by x squared plus 1 look like any of our derivative rules? Like the outputs. It does look like arctangent. So remember that my derivative of arctangent of x is equal to 1 over x squared plus 1. Which means that I go in the opposite direction. The antiderivative of 1 over x squared plus 1 is going to be arctangent. And again, plus c at the end, which is a nice reminder, because in our next section, we're going to be looking at all of those inverse trig functions, as well as completing the square with them. Yes, ma'am. Alright, what questions do we have there? Alright, that's all we have for today.